Dear students, I welcome you all to this physics teleteaching class. So, in previous lectures, we discussed about the electric field intensity due to a point charge. Now, when many charges are discretely distributed, then how to find electric field intensity? Let us see. So, these are the many charges discretely distributed and the position vector r1p is from at point P relative to O. So, the distance between the charge q1 to P is r1p, and we know for point charge, for positive point charge, electric field is directed away from the point charge. So, it is outward. So, E1 vector, the electric field line will be outward. Then for other charges, the directions of electric field are shown in the figure. Now, when all the electric fields are superposed, we get a resultant electric field ER by drawing a parallelogram law. Okay. So, what is the resultant electric field? By using principle of superposition. Let us know what is the principle of superposition says. Principle of superposition says electric field at a point due to a system of charges is the vector sum of the electric fields at the point due to individual charge. That is ER, E resultant at point P is equal to E1 plus E2 up to En. If there are n number of charges, then it will be equal to a summation over I stands from 1 to n EI vector. If I is equal to 1, then it is E1, if I is equal to 2, then it is E2, and like that. Okay. So, by using principle of superposition, when 4 number of charges are discretely distributed, we find the resultant electric field is E1 plus E2 plus E3 plus E4. Then by putting the expression of electric field intensity, we find that ER is equal to 1 upon 4 pi epsilon naught summation over I stands from 1 to 4 as there are 4 number of charges Qi upon RIP square into RIP cap. Okay. So, this is all about electric field intensity due to a point charge and discrete distribution of charges. Let us do some numerical. First, it is asked in the numerical, find electric field at a point 2 1 due to an electron placed at the origin as shown in the figure. So, students, take a click from your mobile and solve it, which one will be the right answer, and I am solving also here. Here the electron is present at the origin and we wish to find at 2 1 position the electric field intensity. Okay. Then the position vector at of point P relative to O is R vector. Okay. So, what is R vector? Yes, R vector is 2 1 position, that means 2 I cap in x axis and 1 j cap in y axis. Okay. And what is R? R is 2 square plus 1 square root over, that is equal to 4 plus 1 5, so root 5. What is R square? Is 5. Okay. So, what is the formula of E? E vector is equal to K Q. Q means here the charge of electron, that means I can write that is minus E, okay, upon R square into R cap. that is equal to, what is the value of k? That is 9 into 10 to the power 9 minus here into, what is the charge of one electron? It is 1.6 into 10 to the power minus 19 upon r square. What is r square? Yes, 5, and here r vector. We know r vector is, sorry, r cap is r vector upon r. This r means r magnitude. So, I can write here r vector upon r. So, this will be equal to minus 9 into 10 to the power 9 into 1.6 in 10 to the power minus 10 upon 5, r vector here 2 I cap plus 1 j cap divided by r here 5, root 5. Okay. So, by solving this we get minus 1.44 into 10 to the power minus 9 upon 5 root 5 into 2 I cap plus 1 j cap. So, multiplying minus here I get 1.44 into 10 to the power minus 9 upon 5 root 5 minus 2 I cap minus 1 j cap. So, here the option C is the right answer. Okay. Here is another problem and it is your homework. Take a click from your mobile and solve it yourself at home. So, we discussed about electric field intensity due to a point charge and discrete distribution of charges, that when a system of charges are there, how to find electric field intensity we discussed. Then now we will study another case, that suppose two opposite point charges are separated by some distance, some finite distance. Two opposite point charges, that is here suppose plus q and minus q, are separated by some distance 12, then this constitutes what, and how to find electric field intensity at any point. Suppose here and also here, at any point how to find electric field intensity, and what the system is called? This system is called electric dipole. Electric dipole. Di means what? 2. So, that means 2 poles. Okay. So, we will know more about what is electric dipole, and then we will study how to find electric field intensity at any point. So, dear students, let us know what is electric dipole. An electric dipole consists of two equal and opposite point charges. Those are separated by a small distance. Okay. Here you can see minus q plus q are separated by a distance 12. Okay. For example, you can take a common salt, that is NaCl molecule. Okay. So, what is the total charge of the dipole? The total charge of the dipole is 0, that is plus q minus q is equal to 0. What is dipole center? See, the center is marked here C. So, the dipole center is the midpoint of location of two charges is called the center of the dipole. What is dipole axis? The straight line passing through the two charges represents dipole axis. Okay. What is dipole length? The separation between the two charges 2L is called dipole length. What is dipole field? The electric field produced by a dipole is called dipole field, you know very well. Okay. Now, let us know the most important, what is dipole moment. So, it is the effectiveness of dipole is called dipole moment P. Okay. So, let us know what is effectiveness. So, when a dipole is kept inside an electric field, then a couple of force will act. You are seeing this figure, a couple of force will act, that means torque is produced. So, due to torque, dipole rotates like a cycle handle also. So, you know torque is R cross F, that means it depends upon the charge separation and the quantity of charge. More will be the separation or more will be the quantity of charge, more will be the torque, and that will be more effective. So, like torque or quantity, dipole moment also depends upon the distance, the separation between the charges and the quantity of charge. That is called dipole moment. Moment means torque, you can say. Okay. So, as it is a vector quantity, so it has some direction. So, its direction is from negative to positive. Then the question comes in your mind, why the direction of dipole is from negative to positive? You see, when dipole is inside an electric field, suppose inside a capacitor, then due to torque it rotates, isn't it? That means it is aligned with the electric field to acquire stable equilibrium. So, to maintain stable equilibrium, the dipole is aligned from negative to positive with the electric field. So, as it is from negative to positive with the electric field, so its direction is from negative to positive, that is minus q to plus q. Then, so the strength of the dipole is called dipole moment. Mathematically, we can write P vector is equal to q into 2L into P cap. So, P cap indicates the direction from minus q to plus q. What is its unit? Q into 2L, that is coulomb into meter. What is its dimension? M0, M0, L1, T1, A1. Okay. What is an ideal dipole or point dipole, or you can say pure dipole? See, such dipoles have large charge and separation between them is infinitesimally small. That dipoles are called ideal dipoles or point dipoles. But it has some dipole moment. Dipole moment is not 0, it has some finite dipole moment. Okay, clear? Let us know what are the physical significance of electric dipole. Many physical systems from molecules to TV antenna can be described as electric dipoles. You can see the molecule, for example, water molecule is the best polar solvent, and here also you can see the picture of TV antenna. Okay. Then we will discuss atom as a dipole. In first picture, you can see in the absence of electric field, the centers of negative charges and positive charges coincide. So, that does not form a dipole. A dipole when it is formed? When two opposite equal charges are there, are separated by some distance, then dipole is formed. As the center of negative and positive coincides, so that does not form a dipole. So, that means dipole moment is 0. Okay. But when it forms a dipole? When it is placed in the presence of electric field. Okay. When it placed in electric field, then due to electric field, the centers of positive and negative charges displaced and forms a dipole, and atom has some finite dipole moment, and here the centers of positive and negative charges do not coincide. Next we will discuss what are the nonpolar molecules and what are the polar molecules. See, dipole moment is the measure of net molecular polarity. So, by knowing the dipole moment, we can know which molecule is polar and which molecule is nonpolar. Then what are the nonpolar molecules? In most molecules, the centers of positive charges and negative charges coincide, called as nonpolar molecules. For example, CO2, carbon dioxide, CH4, etc. Their dipole moment is 0. Why? Because the centers coincide, and they develop a dipole moment called as induced dipole moment when electric field is applied. Then what are the polar molecules? In some molecules, the centers of positive charges and negative charges do not coincide. So, called as polar molecules. For example, H2O, NaCl, and their dipole moment is non-zero. That means they have a permanent dipole moment even when electric field is absent. So, let us know more about water molecule. You see, the chemical bonds displaced the negative charges and the positive charges. The negative charges on oxygen end and the positive charges on hydrogen end. So, two opposite charges separated by some distance form a dipole, and their dipole moment is from negative to positive. Its direction is from negative to positive. And water molecule is an excellent solvent for ionic substances like salt, that is NaCl we are using daily in our life. If water molecule was not a dipole, then it would be a polar solvent, then it would not be a polar solvent, and hence no chemical and biochemical reactions would have been possible. So, we see our existence as living being depends on electric dipole. So, you can see that how much important the dipole is. So, in the today's class we discussed about first we discussed about what are the fields, what is we saw what is a spider web, that the field is visible, and in gravitational field, magnetic field and electric field the field is invisible, and gravitational and electromagnetic field, that is magnetic field and electric field, are always around us as they are long range. Okay. And also we discussed about what are the fields, and we also saw a demonstration also about electric charges and the electric field, and we discussed about the electric field intensity due to a point charge, due to discrete distribution of charge configurations, and we solved a numerical also. Then we discussed about the electric dipoles, and we saw how important the electric dipole is. Okay. Now, we will calculate the electric field intensity at two positions, first at the axial position and then at equatorial position, and then we will find the electric field intensity at any point. Now, let us see how to find electric field intensity at the axial line of electric dipole. See, what is the direction of electric field intensity on the axial line and on the equatorial line. Let us see. I said that two opposite point charges are separated when separated by some distance, then it is called electric dipole, and this is the axis of dipole, that is dipole axis. And when we take a point, suppose P is the observation point, and we have to find the electric field intensity at that point. Then what is the direction of electric field intensity here? We know from dipoles that the electric field for a positive charge is outward and for a negative charge is inward. Okay? So, the electric field, direction of electric field is outward for a positive charge and inward for a negative charge. And you know that as I discussed, the direction of dipole moment is from negative to positive. Okay. From negative to positive, the direction of dipole moment is from negative to positive. So, you see on axial line, this is the axial line. So, on axial line, the direction of dipole moment along the direction of electric field. Okay. Then what is this equatorial line? Here is the, suppose the equatorial line is like this. Okay. Suppose here is the point of observation and we used to find electric field intensity at this point, then this is our equatorial line, or we can say it is perpendicular bisector. That means it is perpendicular and bisects the line. It is also called perpendicular bisector or equatorial line. Okay. See here, the direction of electric field will be like this, and we can visualize more with the help of electric field intensity, electric field lines. We can visualize more from the electric field lines. So, you can see the direction of on equatorial line, the direction of P is opposite to direction of electric field. Okay. So, on axial line it is along E, and on equatorial line it is opposite to E. Then we will discuss how to find electric field intensity at any point in the next lecture. Okay. So, we discussed today about electric fields, and we discussed the more important part, that is electric dipole, and in the next lecture we will discuss the more about it. Thank you.